In this lesson, we're going to practice naming alkenes and alkynes. I've put a link in the video description to blank copies of these problems, so you could practice by solving them first and then watch the video if you'd like. Let's get started with a problem that involves an alkene and an alkyne in the same molecule. As always with nomenclature problems, we need to start by identifying our longest carbon chain. If we count from this end, 1, 2, 3, 4, 5. And if we count from up here, it'll be the same, 1, 2, 3, 4, 5. So we can circle either this or this chain here. Now we need to figure out which end to number from, this end or this end. Well, we want to use the end where we hit the multiple bond first. So we're going to start numbering here on the right. Okay, now let's put together our suffix. At the 4 position, we have a group hanging off. That's a methyl. So we're going to begin this name with 4-methyl. Now we need to name our chain. It has 5 carbons, so it would be a pentane. We have an alkene and an alkyne in it, so it's actually going to be a pentenine. I stopped at pent here because now we actually need to define the position within the chain where we find our alkene, since we're naming this as an enine. The alkene begins at the 3 carbon, so we need to add in a number 3 before we define our alkene. Now, if there just were an alkene, this would be ene, but since we're continuing the name, we have to drop that final e to tell where our alkyne is. Our alkyne is at the 1 position, so actually we can completely leave it out and just write enine, or we can define it a little bit better using the number 1 because the alkyne begins at number 1 in the chain. Putting it all together, this compound is 4-methyl pent 3-ene 1-ine. Let's do another enine example. Here, we've added on just an extra methyl group, so we know that's lengthened our chain by 1, and we can circle it in the same way as we did on this example. Now, we need to figure out which end to number from. If we look at this, we see if we numbered here, the alkene would be at the 2 position, 1, 2. Ooh, and the alkyne would also be at a 2 position. So when we're given this choice, we pick the alkene to number first. So in this case, we're going to number from left to right. Let's go ahead and add in our prefix. Okay, now we have 6 carbons in our chain, so that's hexane for the parent alkane. So let's write on our hex. Now, even though the numbering priority favored the alkene, the suffix is set up the same, so this is still an enine. Now our alkene starts on the number 2, and our alkyne begins on number 4. Putting that all together, we get 2-methyl hex 2-ene 4-ine. Okay, let's try a cyclic example. Here we have 1, 2, 3, 4, 5, 6 carbons within the ring, and we want to number so that this bromine atom is number 1. Now we need to figure out if we number clockwise or in the counterclockwise direction. The answer here is clockwise because we want to number each end of the alkene first. So we continue along this alkene, the 2nd position gets the 2, and then we can finish numbering our ring. For 6 carbon atoms, the parent alkane would be cyclohexane, so we're going to use the hex name in our suffix. What about our prefix? Well, we have 1 substituent at the 1 position, so we'll write in 1-bromo cyclohex to start. Now in this example, we have a diene. We have 2 alkenes within this molecule. And so we would usually drop the A, but in this one, since it's going to be followed by diene, we'll put cyclohexa. Now we need to define where these 2 alkenes are within our ring. This one starts at the 1 position, and this one begins at the 4 position. So we'll add in those numbers into our name here. The final part of our name is diene to account for our 2 double bonds. Let's try a few more alkenes and practice double bond geometry. Here's our example. Our longest carbon chain is kind of obvious, going just right across here. Now, which end do we start numbering from? We want to number so that we hit the double bond first, so we'll start on the left. Now, to start our prefix, bromine, B, comes in the alphabet before C for chlorine, so we'll start with bromine. I went ahead and added the chlorine in there too. Now we need to specify where our double bond begins, and that's on carbon 2, so we can add on the suffix 2-ene. But there's something special about this molecule that we haven't talked about yet. Here, there are 2 different groups on this side of the double bond, and here there are also 2 different groups. On this side, on carbon 2, we have chlorine and a methyl, and on carbon 3, we have methyl and a hydrogen atom that's implied that I've not drawn in. In our first example, we had the same group on carbon 2. We had 2 methyls. But the chlorine here could be on this side of the bond or this side of the bond, and that would make a different molecule. So we actually need to define where chlorine is. So taking both sides of the double bond, we want to figure out if the high priority groups are on the same side, which would be a Z alkene, or on opposite sides, which would be an E alkene. To do this, we pick the group with the higher molecular mass. So on carbon 2, this is going to be chlorine. Now on this side, on carbon 3, we have a hydrogen atom, the lowest mass compound that we can have, and a carbon. So this side is our higher priority group. These 2 groups are on the same side of the alkene, so this is a Z alkene. That designation goes right out in front and is very important, so don't forget it. Here's another example. Obviously, our longest carbon chain is here. I'll go ahead and circle that. Let's number our carbons, starting near the end with the double bond. 9 carbons makes this a non-ene. Let's write up our prefix first. Chlorine is at the 8 position, so 8-chloro. And then we have a non-2-ene to define where the double bond starts. Okay, now we need to think about our double bond geometry. Let me add in the hydrogen atoms. So on either side, the choice is between hydrogen and carbon. Here at carbon 2, we have a hydrogen atom and a methyl. The carbon atom is going to have the higher priority. And on carbon 3 right here, we have an H and a carbon atom. And so this group over here gets higher priority. We can see from our stars that the higher priority groups are on opposite sides of the alkene now. This is an E alkene, so we'll put that right out in front. I was once taught a funny trick for remembering double bond geometry. For the Z alkene, the high priority groups are on the same side, so you can say on Z same side to remember this. Let's do a final example. Okay, at first glance, this looks almost identical to this problem, but it's in fact very different. When there's an alcohol in the molecule, it takes priority over the naming of the alkene in both numbering and in the suffix. And so this compound is named as an enol. And we start numbering from the side closer to the alcohol. We again have an E double bond, so let's start with that. Then we get our non-ane part of the name. The alkene begins on the 7 position now, and the alcohol had priority and is the last part of our name. That's at the 2 position. Okay, let's summarize the major takeaways from this lesson. Numbering begins at the side of the molecule that first hits the alkene or the alkyne. But if you have a choice, you number so that the alkene gets the lower number. When numbering in rings, make sure you hit both carbons of the double bond first, and then continue around your ring. If we think about splitting the double bond in half, when there are different groups on either side of this double bond, we need to think about Z and E geometry. Finally, we saw that alcohols have priority over alkenes in both numbering and in the suffix. KP here. If you learned something, give me a thumbs up on the way out, and for more chemistry, subscribe to my channel.